Let's talk do-it-yourself solar setups, from a large RV to a smaller trailer, a van build, or maybe just a portable system. Hey everyone, I'm Kevin and I've been full-time RVing with my wife and 2 kids since the beginning of 2018. Our videos on our big solar install have been pretty popular, so I thought I'd talk about the process I went through to design it. This video will be the first in a 5-part series on planning and designing a solar system that meets your needs, whatever your power goals happen to be. I've got a little over 2,600 watts of panels on our roof, and I definitely wouldn't say that that's for everyone. And real quick, I just wanted to throw a couple of other things out there. I have a background in engineering, but I really don't think that's necessary to pull this off. I'm not going to tell you that a complete solar setup is simple because it's not, but like anything else, if you break it down into its parts, it's not overly complicated. I'm also not a professional solar installer, so do your own research as well. This is all based on my experience making our system. Each of these videos will have chapters in the description, so you can feel free to skip ahead as needed. Next, I'm going to cover the basics of RV electrical systems and some terminology. Then I'll talk a little bit more about our particular system and why we went with what we did. Alright, RVs have 2 very different electrical systems. There's the 12 volt system and the 110 or 120 volt system. Think of the 12 volt system as something very similar to a car, and the 110 or 120 volt system as what you would get in a regular house. The 110/120 side is AC or alternating current, while the 12 volt side is DC or direct current. To keep from going too far down the rabbit hole, if you want to know more about direct current versus alternating current, hit pause and go look that up real quick. Otherwise, it should also be noted that neither one of these systems actually operates on the exact voltage that they are named for. The 12 volt system is powered by your battery or battery bank if you have more than one. It actually operates anywhere between about 11.5 to about 14.7 volts. At 11.5 volts, that would mean that your battery is pretty much dead, while 12.6 volts is what a regular deep cycle battery looks like when it's fully charged and the battery charger is not running. A regular deep cycle battery is typically what an RV comes with. Anytime your battery charger is on, you'll see voltage in the mid-13s to 14s. Anyway, this powers your lights, water pump, fans, slides, motors for your jacks or a leveling system, awnings, and sometimes your fridge. If you have a power port that looks like a cigarette lighter style one in a car, that's also run on your 12 volt system. Sometimes RVs are made with USB ports that are also run off your battery so you can charge your smaller devices. Next, the term 110 or 120 volt system is used interchangeably. It's what you get when you're plugged in at a campground, and mostly just think of it as a standard household electrical plug. In a house, this is usually between 114 to 126 volts. Campgrounds, let's just say that the surge protector or EMS that we use will allow anything between 104 to 132 volts. Campground wiring is sometimes a little bit hokey, but it still works. So normal voltage is actually a really wide range. Outside of your regular outlets, this side of your electrical system also powers your air conditioner, microwave, the electric side of your water heater, your converter, which is also known as your battery charger, and once again, sometimes your fridge. We'll talk more about refrigerators in the next video. The last thing I want to mention here before we move on is how these 2 systems interact. Mostly, they don't. Just kidding. The biggest interaction is that any RV I've ever heard of charges the battery, the 12 volt system, when the 120 volt side is plugged in. This is normally done via a device called a converter. It's often hidden away inside your breaker box, and they're specifically designed to work with regular deep cycle batteries that pretty much all RVs come with. I mention that because I'll touch on that again in the battery and inverter video later. Volts, amps, watts, amp hours, and watt hours. Let's cover some terminology to make sense of what's coming later. Think of electricity like a water pipe. Voltage would be water pressure, and amps or amperage would be the amount of water moving through that pipe. Something interesting to note here is that if you move a lot of amps through a wire, it gets hot. Next, let's talk about wattage. Also known as power, this is just volts times amps. So to run an appliance like a microwave or a hairdryer that runs on 1500 watts, which is pretty accurate, running that on your 120 volt system means that you're pushing 12.5 amps through that wire. 120 volts times 12.5 amps is 1500 watts. Now let's pretend you wanted to run a 1500 watt appliance off your 12 volt system. Your microwave obviously isn't designed for that, but there is such a thing as a 12 volt water heater, so let's go with that hypothetically. To run a 12 volt water heater that needs 1500 watts of power would require 125 amps. That's enough to create some serious heat in a wire. My point here is just that it's always better to operate a high power appliance at higher voltage. It wastes power to generate all that extra heat. Sometimes we just do what we can with what we have, but again, we'll talk about compromises in a later video. So we've covered volts, amps, and watts. Two more terms I wanted to touch on here are amp hours and watt hours. These are amps or watts over a period of time, an hour obviously. And these are how batteries are rated. Batteries just store power. So if a lithium battery is rated at 12 volts and 100 amp hours, you can hook it up to a 12 volt system and theoretically pull 1 amp out of it for 100 hours straight before it's dead. Or 2 amps for 50 hours. Or 100 amps for 1 hour. You get the picture. Watt hours is another useful way of thinking about how much power is stored in a battery bank, especially in situations where you might be operating at a different voltage. So a 12 volt 100 amp hour battery stores 1200 watt hours. In our case, we have 6 12 volt 100 amp hour batteries or 7200 watt hours in our battery bank. You could also refer to that as 7.2 kilowatt hours. Again, we'll get into this kind of stuff more when we talk about batteries in another video, but I wanted to cover some of the basics and the terminology. All right, if you've stuck it out this far through the video, would you mind hitting the like button? I would really appreciate it. So I mentioned we have 6 100 amp hour batteries to go with our 2625 watt solar system. That's actually an oversized solar array for that battery bank. When I set out to design our system, my goal was to be able to run our AC units in the summertime when the sun was shining. And that's exactly what it does, but it takes a lot of equipment to run high power appliances. We have 2 3000 watt inverters, and I just realized I haven't talked about inverters yet. So earlier I mentioned a converter is actually a battery charger. So a converter uses power from your 120 volt system to charge your 12 volt batteries. An inverter does the opposite. It uses power from your batteries to power your 120 volt system. This is how you get regular 120 volt power when you don't have a connection at a campground or to a generator. I mentioned the design goal of our system because that's honestly the very first step in designing your own solar system. What do you want to run when you're away from a campground? How much power do you typically use on a day? Are you headed into the desert in the Southwest for a week and just want to run some lights, fans, charge a phone, and run a laptop? That's a way different power scenario than running a coffee maker every morning, TVs and a residential fridge all day, and a furnace all night long. That's all covered in part 2, where now that we've covered the basics, you'll be ready to make your own design goals.